Good morning. Today we are going to discuss equivalent circuit of single phase induction motor and also no load and block rotor test. To draw equivalent circuit, we have two methods, double revolving field theory and cross field theory. While in double revolving field theory, we have to consider two conditions. Only main winding is energized and rotor is stationary. So we all know about double revolving field theory. There are two equal and opposite fluxes revolves and makes the rotor pulsating. So that only pulsating, that is not rotating. So that condition is applied here. So while in this condition, motor behaves as a single phase transformer with its secondary short circuited. This is the equivalent circuit. Only its main winding is energized. So this R1M and X1M, these are the stator parameters, and IM is the main winding current, and VM is the supply voltage. VM is the supply voltage, E1 is the induced EMF in main winding, and XM is the leakage reactance of a main winding. R2 dash and X2 dash are rotor parameters. Here, while single phase supply is given to the stator winding, two equal and opposite fluxes rotates, they have equal strength. So this magnetizing reactance is divided into two parts, equal parts, that is XM by 2 and XM by 2. So the rotor parameters are also divided into two parts. So we have two shunt branches, and due to that two fluxes, forward flux and backward flux, we have two induced EMF, capital E EMF and capital EMB in main winding. So the overall reactance of the overall impedance can be found that as ZF and ZB. Here, the effective rotor resistance with respect to the forward rotating field is R2 dash by 2S, and with respect to the backward field is R2 dash divided by 2 into 2 minus S, where this S is where this 2 minus S is the slip of backward rotating field and S is the slip of forward rotating field. So our resistance become variable now. So this can be shown as equivalent rheostat or variable resistance. So in order to find the ZF and ZB, the shunt branch is in parallel with the impedance, that is magnetizing leakage reactance. So this effective resistance gives ZF and ZB. So this, the circuit in the left side, this shows simplified equivalent circuit, while this is the approximate equivalent circuit. Those in the right hand side is the approximate equivalent circuit. It has two shunt branch and one series branch with the supply voltage and the main field current. So from the simplified equivalent circuit, we can find the total current, supply current, IM, main field current. IM is equal to supply voltage divided by the overall impedances, where Z1M is the impedance of stator circuit. In order to find the parameters of the equivalent circuit, we need data from no load test and block rotor test. So this is the circuit diagram for no load test and block rotor test. No load test is otherwise called open circuit test, and block rotor test is otherwise called short circuit test. And the measuring devices in these circuits gives the data for our equivalent data, and that data can be used to determine the parameters for equivalent circuit. This is the procedure for no load and block rotor test. In no load test, we'll apply the rated voltage. The rated voltage can be applied to the stator. This is because the voltage iron loss is directly proportional to the voltage. So we are applying the rated voltage. And the wattmeter measures the input power, and voltmeter measures the standard rated power, and ammeter measures the no load current. Here the total wattmeter reading is equal to iron loss plus stray loss plus mechanical loss, plus stray losses. And in the block rotor test, the rotor is to be blocked by applying some amount of by applying some the mechanical load, and also at that time only the reduced voltage of order 5 to 8 percentage of the rated voltage has to be applied to the stator by using the single phase auto transformer. And voltmeter measures the short circuit voltage, ammeter measures the short circuit current, and the wattmeter measures the copper losses. This is the approximate equivalent circuit, and the parameters in the circuit can be found from the following formula. So no load open circuit, no load test, and these are the formulas obtained from the no load test, and this formula is similar to those in the single phase transformer shunt branch formula. The same formula is used here. And the block rotor test, short circuit test, we have to find the parameters of the shunt branches. Okay, does rotor resistance refer to the stator side, rotor reactance refer to the stator side, and stator winding reactance, and magnetizing reactance XM. All these can be found from the block rotor test. This is the shunt series branch parameters, no, and all these parameters can be shunt branch parameters can be obtained from the block rotor test, where here R1 is the stator resistance. It can be measured. So thank you.